Let's look at this next question. We have two electrons which are separated by the distance 2d over here, and here at the midpoint of these two electrons there is a proton which is placed. The proton has mass small m and it is placed at a midpoint, and what they are saying is that they are displacing this proton perpendicular to this line by an amount x, and note that x is given to be very less than d, right? It is very less than d. Okay, so now if I displace this proton by this much amount, it will be here, or you can take it downwards as well, no problem, right? But it is perpendicular to this horizontal line. Now what they are asking is that it will do a simple harmonic motion, and what will be the angular frequency of that SHM. Okay, so how will we do this question? First of all, see, this is a proton which is positively charged, of course, plus q. That proton has a charge plus q, and the electrons is e, right? So plus q is of course is equal to plus e only, right? Okay, now this minus e will attract this proton along this direction, right, towards this one. Okay, and this electron will also attract this proton in this direction. So now there are two forces along this line. Okay, now but this distance of electron from the proton is d, and this proton to electron distance is also d, right? Now this is a right angle triangle, this triangle is a right angle triangle, so I can say this distance is square root of x square plus d square, and this distance is also square root of x square plus d square, right? Now the two forces are being applied in these two directions, right? So they have the resultant, right? So let's say this angle is theta, so by symmetry this angle is also theta, right? So I have this one force F and another force F again in the same magnitude, right? Both of them are having same magnitude, and their components in the vertical direction will be F cos theta. So if I see this proton over here as this with the E charge, so downward force is going to be 2F cos theta, right? And these two components F sin theta and F sin theta will cancel out each other, so net force will be downwards, which is 2F cos theta, right? 2F cos theta. Okay, now what is F? If I find out the magnitude of F, it is going to be K, Q is nothing but E, K E square divided by the distance square, this is x square plus d square, right? Correct? Now I will put this value of F there, but what is cos theta? What is cos theta? The cos theta angle, the cos theta will be adjacent side upon hypotenuse, that is x upon square root of x square plus d square. So this is square root of x square plus d square. Now the net force is 2F cos theta, so the net force can be written as 2F cos theta, which is 2k E square divided by x square plus d square, x square plus d square into cos theta, which is x upon square root of x square plus d square, right? Okay, so the net force will be nothing but 2k E square x divided by x square plus d square to the power 3 by 2, right? Correct. So this is your net force. Now this net force, if it is directly proportional to x, then I can equate it to that F is equal to k dash x, right? Where k dash is the constant of proportionality. So if from that k dash we can find out omega, as I have said in the previous question. Now the thing is, x is very less than d, correct? So what I am going to do here is I am going to take d, x is very less than d, right? Okay, so I can take the d outside, so it will be 2k E square x upon, if I take d outside, it will be dq plus 1 plus x square by d square to the power 3 by 2. Now see, what is the ratio x by d? X is already very less than d. So if x is already less than d, then x by d is very small, right? D is very greater than x. Now if I square it, suppose x by d is very small, that is x by d is equal to 0.00001. So if I square it again it will be very small. So that means this can be neglected and this can be taken as 0. So here if I can see, it will be 2k e square x by d cube, right? Okay, now we can put the value of k. So this is f net, right? F net. So if I put the value of k, it will be 2 into 1 upon 4 pi epsilon 0 e square divided by d cube. This is the value of k dash, which is the spring constant, you can say. So this will be 1 upon 2 pi epsilon naught. This is e square divided by d cube, that is k dash. But now what is omega? Omega is nothing but square root of k by m. So omega is equal to square root of k dash by m. What is k dash? E square upon 2 pi epsilon naught m d cube, where m is the mass of that proton. So this is going to be your answer. This angular frequency is the frequency with which this proton will oscillate up and down. Note that if I take it upwards, the net force is downward. If I take it downwards here, the displacement, again these two electrons will apply a force in this direction and their net component will be in this direction. So you can see always the force is directed towards the mean position, right? So this is correct only if x is very smaller than the t. Okay, so let's look at the next question, which is very important question because that is occurred in JEE Advanced. Okay, we will see that next question and I will erase this first.